Hey team, if you are absent, you have a new lesson today. My projector went out, so it's going to look a little bit different. We're going to work on pen and paper. A few key players to get familiar with. A proportion is when you create two equal ratios. And if you look at 10 over 2 and 25 over 5, you can create the ratios 5 over 1 if you simplified it. 10 divided by 2 is 5, 25 divided by 5 is 5. You would say these are proportional. Proportions always have the same unit rate. So notice how when you simplify them, they kind of look like a unit rate. They have 1 on the bottom. They always will have the same unit rate if they're proportional. You would read this proportion like this. 10 is to 2 as 25 is to 5. Those are proportional. 10 is to 2 as 25 is to 5. You can always check if things are proportional by simplifying. If they simplify to the same ratio, like 5 over 1, you can say yes, it's proportional. So the first example wants us to identify if each set forms a proportion. Is 1/3 proportional to 5 over 15? So let's take each fraction, and 1/3 is as simple as it gets. But 5 over 15 can simplify. Let's divide top and bottom by 5. 5 over 15 is the same as 1/3. If you simplify the two fractions and they equal each other, your answer is going to be yes. They form a proportion. Let's try 4 over 6. Simplify this, and if you're uncomfortable simplifying, a good trick is to start with the top number, like 5. 5 divides evenly, but 4 doesn't divide evenly. So if you get to something that doesn't use the top, you're going to start with 2. My default is just to begin with 2 and see if it works. 2 goes into 4 and 6 and makes 2/3. Let's try 16 over 18. 16 won't divide, but I can try 2. And it makes 8/9. So let's compare it. Does 2/3 equal 8/9? No, those are different. So my answer is no, they're not proportional. Let's try 2 over 14. Simplify that. 2 can go evenly into 14 and 2, so let's use the top number. Let's try 6 over 42. Let's see, 6 goes into both as well, so let's use the top number. 1/7 equals 1/7. Yeah, those are proportional. Let's try the next one, 5/7. I tried to simplify that, but there's no number that divides evenly into 5 and 7, so let's leave that the same. 25 over 30. 25 can't divide, but I could try 2. 2 doesn't work for 25. 3 doesn't work. 4 doesn't work. Let's try 5. I get 5/6. So compare those. Those are not the same. They're really close, but they have to be exact. This would be a no. That is solving proportions by simplifying. There's another strategy called cross products. The best mathematicians are really good at both of these strategies. You could probably look at this and come up with a way to simplify it and automatically say, yes, 2/5 would equal 2/5. But what if I told you there was an alternate method called cross products? If something's proportional, you should be able to multiply across and get the same number when you're multiplying the other way. So if you multiplied 5 by 4 to 20, the proportion would work as well if you did 2 times 10. I got the same number. If you have the same number on both sides, you automatically know these are proportional. Let's try that for this one. You can also circle them if it makes it easier to see. 1 times 9 is 9. 3 times 3 is 9. Yes, those are proportional. Let's try this one. 1 times 12 is 12. 6 times 3 is 18. No, those aren't the same. If you get two numbers that don't equal each other, you can't say they're proportional. Those won't work. You could have simplified this also and gotten 1/4, but cross products is sometimes simpler than trying to simplify it. Okay, if you're at home, go ahead and complete the bronze problems, first page 1 through 8. And I'll check back with you when you're in class. That's the way the cookie crumbles. Have fun.